My name's Javier. I'm one of the maintainers for the Cloud Native Buildpacks project. I've been a developer for maybe about 10 years plus, and always been a DevOps liaison, working very closely and trying to get whatever application we've got going to production. Yeah, I'm here joined with Matt McNew. Matt, you want to give your little intro?
Yeah. Hi, everyone. I'm Matthew McNew. I work at VMware, kind of collaborating pretty closely with the Cloud Native Buildpacks project that Javier is working on to help build a platform that runs Cloud Native Buildpacks on Kubernetes called kpack. So hopefully we can dive into that a little later in the presentation.
Cool. So I guess what we have today is I want to kind of go through some development workflows before we explain what Cloud Native Buildpacks really is, and really talk about how we work between app developers and DevOps, and what things Buildpacks can do to then help do that, right? And then we'll kind of dive a little bit deeper into how they work on the internal side of things, and then finish it up with some demos for Pack, which is the CLI that the Cloud Native Buildpacks project maintains, and kpack. So first, the development workflows. So before we had containers, right, we had this workflow where DevOps was introduced to maintain the environment, whether it be staging or production servers, and they were responsible, along with app developers, to try to coordinate how you would take the application source code or binaries into that server, right? And so typically this involved a heavy handoff in collaboration, but still the responsibility was on the DevOps side, more or less to focus on making sure that the compliance, security, and performance was there to maintain that application running long term. But this handoff was, still one of the biggest pain points. So one of the things we did was we said, hey, just give me a container, right? We'll use the term container image here, but give us a container. You put your application into it. We'll still inspect it. We'll still make sure it's secure, it's performant, and it has the configuration, elements or attributes necessary for us to put it wherever we need to put it. And this works really, really well, right? Like, this minimized a lot of the handoff. The DevOps team could focus on the infrastructure and compliance side, and the app developers could, they had the insights to running this application. But it was still, it created new pain points for the app developers. One of them was building these multiple applications, right? Moving on from one application to multiple applications, thereby providing different container images, and making sure that every single time that they produce these images, they had the highest of standards necessary to meet whatever the DevOps team was expecting of them. On the other side, kind of unrelated, is the day two operations from a DevOps perspective. And this is maintenance, right? This is thinking about how do you update your dependencies of the applications that are running, and how do you update the operating system, right? And we'll kind of get into that a little bit. So if we dig into the different pain points, we could talk about how we build applications from an app developer's perspective. And typically, an app developer would use a Docker file, right? And if you look at what the Docker file best practices are, you have things like multi-stage builds, minimizing number of layers, leveraging build cache, and the list goes on and on. You'll probably find a blog post tomorrow about the next newest best practice that you should be using for your application. Then you have app-specific best practices, using different dependencies for the build process versus the run process, making use of the multi-stage for that build process, and so on. How caching is used and how memory allocation should be done. And again, you can kind of keep going down this rabbit hole of newer, better things that you can improve in your Docker file. So overall, that makes it not fun to work with, right? That's still some of the toil that the app developers have to deal with. But not only that, these Docker files make it really hard for you to reuse that same logic across different applications, because every application essentially comes with their own set of dependencies, right? And they're not really composable in a way. So one of the things that I'm trying to depict here is that every application is going to have a different Docker file that then the app developer essentially has to maintain. Okay. Now, going over to the DevOps side, we talked about the dependency updates, right? So you have all these containers out in production, and then all of a sudden there's dependencies that became stale or older, and they found issues within them, right? Normally, this would involve the app developers having to produce new app images for you to be able to update these dependencies, right? Same thing can be said about the OS updates, right? So you've got OS updates. A very common example that we can use here is the Heartbleed scenario that happened, right? Where all of a sudden you had all these operating systems where the distros had already provided the patches for it, but you still had to go back and update these operating system layers. And depending on how big your infrastructure is and how many containers you have out there, this isn't something that you do in a day, right? It's something that takes weeks, months, even more. And so those are the pain points that we're trying to solve. So that's where Cloud Native Buildpacks, I think, really shines, right? It lets app developers build the applications with little to no setup, right? It's the whole premise is that Buildpacks are magical, and you just provide your source code, and they could provide an OCI image with the highest standards. From a DevOps perspective, they enable other mechanisms like rebuilding for updating the dependencies without having to change any of the source code, or updating the OS layers. And as we'll demo later, that's done without any intervention whatsoever, right? So to dig in a little bit deeper into how Cloud Native Buildpacks could actually enable this, we have to look at how they work, right? And at a high level, like the smallest unit of work, these Buildpacks, all they do is they look at your source code, and without the use of Docker files, they're able to produce an OCI image or OCI layers. It's a very simple mechanism, but it's worked very well so far. And this has to do with two operations that a build pack does, and that is detect and build. So during the detect phase, it solely looks at your source code and says, yes, I can run with that, or no, I can't, right? And then if a set of build packs say, yes, I can work with that source code, then we provide this thing called a build plan that specifies all the build packs that are going to be then executed on the source code to produce these layers. So as part of the build process, that's really where the build packs themselves would gather the dependencies. They'll compile the application if it needs to be compiled. And most importantly, set the launch command, which is what will be executed when the OCI image is started. Okay. So that's just like one piece. I know it's like in the title, right, of the project, Cloud Native Build Packs, but there's other components to the system that we should talk about. One of them is stacks, and that's composed of two images, and they're OS images where we have the build image that provides the build time environment where the build packs will execute. And then we have the run image, which is the runtime environment in which your application will execute once you actually run it. Last but not least, we have a builder, which is a format of distributing all the bits necessary to execute this build, right? And because of that, it is relatively larger, and it has the build packs themselves, the lifecycle, which we haven't gone into, but it's essentially the engine that executes the build packs themselves. So it's like kind of the core of everything. And then this image, this builder image, is based on the build image, right? Which then provides that build time environment for us. One thing to note is that the Cloud Native Buildpacks project is actually a spec project at its core. And it provides some tooling and everything, but it doesn't actually provide build packs themselves. We enable, or kind of our goal is to provide the spec that other, third parties could then leverage. And so we see builders right now being provided by Google, Heroku, and the Paketo Buildpacks project. Now, we've talked about all the different players or the different components within the system. One that we haven't really gotten to, and it's more of a higher level object, is the platform. And this is the thing that grabs the source code and the specified builder and executes the lifecycle in this, container, in this build environment. From there, the final output is the application image with very specific, I guess you could say locations of where the different layers will reside, right? And because of this systematic way of building your application image, we can then do something that's kind of speaks to that OS update at least, where we can rebase your application. And what that is really just updating a pointer of saying, instead of using these OS layers, use these other OS layers instead. And because we know where those OS layers are, that's a very easy operation for us to do. And then furthermore, because the OS distros provide this ABI guarantee, this whole system inherits that ABI guarantee, which means that your application behavior is not going to change whatsoever. Okay. So, we talked about platforms, and these are all, what we have here is all the platforms where you currently can use Cloud Native Buildpacks. I'm sure there's some on here that we didn't list just because I either ran out of time or didn't find them. But the ones that we'll focus on today are going to be Pack and kpack. Okay, I guess I'll get started with the demo. Okay, I did pre-record this, so I'm cheating a little bit, but I did this just to make sure there wasn't going to be any network glitches and whatnot. So what we're going to do is we're going to download the samples. And so these are Buildpack samples repo where we have a little bit of everything in here. We'll take a look inside real quick. And as you can see, we've got some apps, we've got some builders, build packs, and then some packages, which is really just how you package build packs for distribution. And lastly, the stacks. What we're going to be looking at is going to be the apps. And one thing to note is that Cloud Native Build Packs should work without any modifications to your application source code. And if you look at these sample apps that we have here, most do not have any alterations to them. There are some files in here that are Cloud Native Build Pack specific, and that's to take advantage of additional, advanced features. The one that we'll be looking at is going to be the Java Maven app. And you'll notice that there's nothing special about it whatsoever. It's got a Maven wrapper, your POM XML, and the source code, plus some Git files. So the first thing we got to determine is what builder we're going to use to build our application. So we'll run the command pack suggest builders. And as you can see, it mentions a couple builders. We have the Google, the Heroku builder, and a few from the Paketo project. The one that we're going to use for this demo is going to be the this base, which is the Ubuntu Bionic base image. And it has a build pack for Java, so that should work just fine. Okay, we're going to set that as our default builder. And this will prevent us from having to specify it every time that we do a pack build. So as I mentioned, alternatively, you could just do pack build and pass -- builder, and everything should just work. But now what we can do is we could actually build our app. So it's pack build, my Java app, pass it the path, right? And the first thing that it's doing is it's downloading the builder. And as I made mention, it could be relatively large depending on what the builder contains. In this case, one of the things to note is that it is downloading it to your Docker daemon. And so you should only be doing this once, right? And then you'd have it unless there's an update to it, which it would then update the only the layers necessary. The other thing to see on or note on here is that it downloaded the run image. And going back to how we described it, that's going to be what your application runs in. Then it detected 6 out of 15 build packs that will participate during our detect phase. We'll skip over analyze and restore for now. That has to do with caching and optimization as part of the engine. But then we start building the application. And this whole output here is coming from the build packs themselves. And it's telling us that there's additional build configuration that you could set. And then these are all the different operations that the build pack itself is doing. And as you can see, it's taking into consideration a lot of security and optimizations for us that we don't have to worry as app developers. Now, this is the Maven build pack executing the compiling of the Java application. And as you'll see, it's a typical Spring Java app, so there's quite a bit of dependencies. And we'll let that finish here. Okay, so it's done. It took about 33 minutes, or sorry, 33 seconds. And then there's other things we could look at is it specified a couple process types, right? This is what can then be executed from your OCI image. The one that we would use by default would be web. Why it specifies 3 different process types with what seem to be the same entry point, I wouldn't know. We'd probably have to ask the Pacato team about. But now we're in this exporting phase, right? And I am pausing it, just FYI. But we see it successfully built our application. Now we've got the My Java app built. And if we look at the Docker images, we'll see a couple things. We'll see that we have in the Docker daemon, we have our run image, we have our builder, and most importantly, our newly produced My Java app image. Okay. So now we're going to run this application just like you would any other application. We're running in the background. We're opening port 8080. And we'll see through this cool, awesome terminal browser with a fuzzy picture of Buildpacks logo that it says, hello, Buildpacker. Okay. I'm going to go ahead and stop that container. And we're going to edit the app slightly. Okay, so from here, we're going to vim and look in the source. We're going to update the index file. And we're just going to add something on here just to see that something changed. Okay, so hello, future build packer. That's you. So we're going to build it again, right? This is the rebuild operation. And I'll pause it here as well. But we'll see 2 things that happened immediately. It automatically tries to pull down any newer versions of the builder and any newer versions of the run image. So what this does is it effectively updates any build pack provided dependencies for you, going back to that maintenance aspect of it, right? So one other thing we'll notice in this second rebuild is that it's making use of cache quite significantly. And then we'll also see the build pack itself taking advantage of that cache. So this build should be a lot faster. Aside from me pausing it, it took 3 seconds compared to the 30+ seconds, right? We still have our process types, and we're exporting the image over here. Now, one thing that you might or might not notice is that it reuses layers as well. And this is on the Docker daemon case. But for registry cases as well, when we're pushing directly to a registry like the Docker Hub, it won't necessarily actually upload the bits that already exist on the registry itself, right? So then there's very micro optimizations to try to make sure that this runs the best that it can. So we've built or rebuilt our Java application. We're going to run it again. Okay. And now we see that it says, hello, future build packer. Okay, let's close that. And we're going to stop this now. So we've talked about how you could build an app really quickly, how you can go ahead and get the newer dependencies that the build packs provide. Now we're going to rebase, right? And rebase, if you remember, is like really just updating or changing the OS layers of your application. So one of the things we're going to look at is this command pack inspect image. It's going to give us a little bit of information that is attached to the app image. it's going to tell us what the base image was that this was built off of. And we'll keep in mind this reference here. And because this is all in the Docker daemon that we're doing this, we'll see that it points to an image ID of the last run image that we had. For the purpose of the sample, what we're actually going to do is we're going to roll back the OS base image. And we're going to point to this tag that I have here. So we've rebased it successfully. And we're going to look again, and we should see that that reference changed, right? 410. So if we look at our Docker images in our Docker daemon, we'll see that now this image here is pointing to the 410, this older, in this case, version of this run image. And just to make sure, we'll run the application one last time and make sure that the application didn't change whatsoever. Okay, there you go. Hello, future build packer. That pretty much concludes the demo. And I could hand it off to Matthew, and he could demo kpack.
Cool. Thanks, Javier.
Thanks, Javier.
Let me go ahead and present. Make sure everyone can see my screen. Oh, one sec.
He just left, right?
Yep. So you guys, you don't work on the same team, right? He works on the kpack and you are on Buildpack only, or do you share some work?
We collaborate as far as like feature requests, right? Because he works on build service as like within the K8s context, and Cloud Native Buildpacks is not, focused in on K8s. It's any OCI platform.
Okay.
So in that way, we do collaborate.
Hey, Matt.
Hey, sorry about that. Looks like I had to restart my Chrome. So, without further ado, can everyone see my screen?
Yep.
Cool. So I think as Javier was mentioning, I'm going to do a quick demo about kpack. Kpack is a Kubernetes implementation of a Cloud Native Buildpacks platform. And what kpack really provides is a mechanism to provide a declarative configuration for an image. So instead of defining a build resource directly and imperatively saying, I want to do this build or I want to do that build, with kpack, you can just apply a configuration for an image that kpack will maintain. And the power behind that is it really allows you to make it easy to manage some of those updates that Javier mentioned. If there's an updated JVM, you can easily stream an update to it and have kpack rebuild. And that's actually what I'm going to demonstrate today. So I have a little visualization right here that has about a handful of different images, all built with different build packs and underlying application source. These are all real images managed by a real kpack install. But as Javier mentioned, we can imagine if there is a critical vulnerability in the stack, or if you want to make sure the operating system for these images gets updated across many different apps running, kpack should be able to manage that. So purely in this demo visualization tool here, I'm going to go ahead and mark the stack that these images are run with to be vulnerable, which is a way in this visualization to really demonstrate what kpack is doing underneath the hood. So all of these images are running with an old stack. And I am going to go ahead and run a pbdemo update command that's going to simulate what would happen in a real production cluster. So running pbdemo update stack, it's going to provide a new stack image to the kpack cluster.
Could you zoom in a bit, please?
Pardon?
Could you zoom in, please, a bit?
Oh, sure. Yeah. So
Thanks.
make this hopefully a little bigger. Everyone see that all right?
And on the terminal also.
Yeah, so on the terminal, I just ran pbdemo update stack, which isn't something that most end users would use. It's just a tool that we've built to demonstrate kpack. And so right now what we see in this visualization is that all of the underlying images that have the old stack have been queued by kpack to be rebuilt. And in the upcoming minute, we should see them get patched. We've already seen a couple of those go through. So this image and this image with some of these funky names are getting updated and now running against the new stack that kpack has automatically done. And what this is doing behind the scenes is actually just doing that rebase operation that Javier showed for every single image that has the old stack. And as we can see, it's already gone through all the images. But it's not just images. It's not just the operating system stack that kpack can manage and update for you. It can also go ahead and rebuild them if there is a Buildpack update. I'm going to go ahead and demonstrate what that would look like as well. So I notice some of these images are built with what appears to be the Paketo Node.js Buildpack, because in all these images, it'll mention the Buildpacks are used. So I'm going to go ahead and do is grab this Paketo Buildpacks Node Engine Buildpack, and I'm going to mark all of the Buildpacks, all the images, sorry, that have been built with that Buildpack as vulnerable. And that should light up them red to show that currently they're running an out-of-date image that was built with an old version of the Buildpack. And in a real-life cluster, you'd be able to apply the new Buildpack to the cluster, and kpack would go ahead and rebuild those images. But for the sake of this demo, what I'm going to go ahead and do is I'm just going to do a pbdemo update Buildpack this time, similar to update stack. And again, this isn't something that end users would do, but it's just something I'm doing to demonstrate this in this demo. I'm going to do update Buildpack. And I'm going to update the Paketo Node.js Buildpack. And what this is actually going to do is generate a whole new Buildpack and update it to the cluster. And in a second, we should see these images were detected by kpack as needing a rebuild. And these rebuilds should be faster because they're going to leverage the same underlying caching that Javier mentioned earlier. And if I drag this up, we should be able to see the logs from this updated build go through. Cool. So that went ahead and finished. In a second, this last image should. As we can see, all of these images are marked green to say there's no updates to apply because kpack has gone ahead and rebuilt them. So that's actually all that I have to show. I was just hoping to give a little bit of taste of what kpack is and how it can leverage a lot of those concepts in cloud native build packs. to run on Kubernetes and make it easier to manage and update a fleet of images, all with different set of sources and build packs. You can learn more about the kpack project on the GitHub repo here, Pivotal kpack, which should be inside the slides. And I think we can jump to questions. I was going to show a final slide, but I had to close Chrome to share, so I don't have that ready at this time.
Are you sure you cannot open another tab or something?
I might just hand it over to Javier, who I bet has it open.
Oh, do I? I don't know. Let's see. Cool. So we've demoed pack, kpack, and this is the community. So yeah, just as a kind of outro, right? I want to say that buildpacks.io, if you want to learn more, we're very active on Slack, Twitter, and then GitHub. As we mentioned, kpack's GitHub repository is also there. And we could distribute these slides, yeah, if to whoever needs them.
Okay, thanks. Thanks very much. It looks like a great project. So I have a few questions. So you talked a lot about Paketo. Okay, could you tell us a bit more about Paketo, what it does?
So Paketo is an independent project, I believe, under Cloud Foundry. And what it does is it maintains essentially the bits, right, the logic for different programming languages so that you don't have to manage it yourself. So like you as an individual or as an organization could create your own build packs, but by going with build pack providers is kind of the term that we should probably be using, is you could just kind of reuse what they have as far as build packs are to then update your application or build your application, sorry. And that also allows them as a community to keep up to date with what the security standards should be, what the latest programming languages or updates are, and all that stuff. So you don't have to do it yourself, right? So we're Paketo is just one of them. Heroku has been maintaining build packs for quite some time, and Google just released their set of build packs here recently.
Cool. So you mentioned Heroku. So I think the build packs were originally used by Heroku for their Rails apps, and I was wondering how would this work with a web framework like Rails for the database? Like, what do you recommend? Should we use build pack for this, or should we just tell the web app to connect to a database on its own? Should the build pack take care of this one or not?
I don't know, Matt, if you have any insight in that. The little bit that I do know in that context from the project as a spec is that really depends a lot on the platform that you're going to be, putting these containers into. We have a recent edition of bindings, which kind of speaks to, how you would connect to additional, services. But again, it's maybe too specific to a platform to then be able to answer that in a very specific form.
Maybe kpack on Kubernetes has an answer for this, or?
We don't necessarily have a direct, any opinionated look at where you'll be able to get your database. But for the most part, the build packs are just going to build the application image and provide pretty well-defined hooks to allow you to provide and mount the credentials to communicate with the database. And we have an experimental binding spec that I think the Paketo build packs support, which will build the app and then can allow at runtime the binding of the database credentials to be connected. And I'm a little less familiar with Heroku's Ruby build packs, but I believe they have some similar mechanism to allow you to build your Rails application, but then provide the credentials to connect to them.
Okay.
Connect to the database.
Mm-hmm. All right. Will those binding work with other type of servers, like not only database, but any kind of service? Is that the goal?
Yes. Yeah, I think, yeah.
Mm-hmm. Okay. Another thing is that, so you mentioned that GitLab uses Buildpacks, and I know they used to run Heroku-ish, and I think they still use it for when they need tests. I know that Buildpack have a build step. Do you plan to add like a test step? Does that make sense?
We are right now. We are soliciting ideas on how to really do that in a general format. We have, at least on our YouTube channel, there was like we were starting to post working group meetings there. In one of those, there was a demo by Tilt, which provides this like development environment or development workflow where they're adding a lot of that kind of functionality, right? So that's just one aspect of like being able to develop. But then if we talk about like other sort of tests, like, unit testing within the same environment, we're kind of maybe tying them together too tightly, but those are things that we're actively working on to enable, the community to provide. But we do need feedback to see and make sure that we satisfy all the use cases that we can. So it's not quite there yet, but we're working on it. And I could link somewhere some RFCs that people could look at.
Oh yeah, that'd be great. Yeah. So we can expect them like by the end of the year, or there's no ETA for now?
There's no ETA, but it's definitely at the top of our priority, I would say, as a project.
Okay, and how about static websites? Do you have Buildpack for this, where it provides like serving first it builds the website and then it serves it? Does that make sense for a Buildpack to take care of this, or?
Yeah, I mean, I would say definitely, right? Like if you want to build, I don't know that a Buildpack exists, right? We're kind of letting the community decide what Buildpacks make the most sense. But if you were to create a Buildpack for Hugo, right, I'm sure people would use it, and it'd be a great project. There's obviously other static website generators like Gatsby, right?
Yeah.
I'm not even sure I'm pronouncing it right, but that all uses JavaScript, which should enable that kind of like standard configuration to run using some of the pre-existing build packs we have now.
Okay.
You might also just check out the Nginx Paketo build pack, which is available today, to provide a mechanism to build an image with static assets.
Oh, could I use this like to build Hugo or Gatsby and then plug in the Nginx Paketo?
Yeah, I think at this time they don't provide direct hooks to build Hugo, so you'd have to build your static assets outside the image. But then you could use the Nginx build pack to serve those assets. But I'm sure the community would love, the Paketo community would love to research perhaps some more of those build pack functionalities to leverage something like Hugo.
This would need to be added to the build pack specs first?
It wouldn't need to be added to the build pack spec. Today you could do it on your own by building your assets on the outside using Hugo, but a new build pack could be created that would actually invocate Hugo.
All right. Well, thanks to both of you. It was really very interesting. And is there anything else you would like to say before we quit?
No, I mean, I think, as I mentioned before, feel free to reach out to any of us. I think would be happy to have you in their community. And any idea, like all the stuff that just came up right now, it'd be interesting to move forward with those, right? And we could answer those offline as well.
All right. Thanks so much, and see you soon then.